Microsoft has dramatically reduced the barrier for integrating advanced analytics into your application across all three of those areas. So by providing highly engineered, highly tested, highly performant and scalable models, it no longer requires the same kind of domain or the same kind of machine learning expertise that it may have historically in crafting custom machine learning models. One of the major things that Microsoft has done in the last little over a year now has been the acquisition of Revolution Analytics, which is where I actually come from, and the creation of the Microsoft R server and Microsoft R services in SQL Server 2016. So I wanted to talk through a little bit of those before moving back into the Azure machine learning world to talk about some of the R and Python specific features. My name is Jamie Olson. At Microsoft, I am an analytics solution architect. So what I do on a day-to-day basis is I talk with partners and customers about the solutions that they're trying to solve and identify the ways in which we can leverage all of the different Azure products and combine them in a end-to-end way so that we can manage the entire solution all the way from, so typically we're talking about data applications and analytics applications, so all the way from the ingestion of the raw data, so bringing the raw data into the cloud, all the way through to serving the product, the analytics product, whether that's a visualization or a prediction, out to the end user. Let's look at a couple of different ways that R and Python, the open source languages, can be integrated into Azure Machine Learning to build more custom designed solutions around advanced analytics and predictive modeling. So, who here is familiar with R? Okay, so we got a good portion of the room. So R is a whole bunch of different things. It is both a language platform that was built in the 90s by statisticians for statisticians. And so it has a tremendous amount of productivity and flexibility specifically around predictive and statistical scenarios. It has native vector data types, and all of the mathematical operations and statistical operations are built with things like numerical stability in mind, so that you're guaranteed certain level of statistical accuracy and mathematical rigor that you don't necessarily get from other general purpose programming platforms. In addition to the core language, there's also a massive community of data scientists. It's estimated now that there are somewhere over 2 million data scientists around the world that use R in their professional work as data scientists. It is consistently in the top 2 or 3 technologies that data scientists list as software that they use on a regular basis. And it's increasingly the platform that universities are using to teach statistics and data science to the new people that are emerging to fill the need in the workforce. But a lot of the strength that R specifically has, as well as Python, and the reason why I mention these as key differentiators for Azure Machine Learning, is the ecosystem that's been built around R. It's not just about the core language features, it's really about the over 7,000 different packages that are built by people all over the world to support all different kinds of advanced analytics need. So these are everything that range from tools to support industry-specific data and industry-specific data formats, tools to support advanced methodologies, state-of-the-art forecasting, time series forecasting tools that are literally built by the academic leaders as they're writing their research papers. So you have access to things that nobody else in the world has access to when you're using R and also Python. because this is where people are now building their research methodologies. So you see a paper come out in a major conference like KDD or the International Conference on Machine Learning or anything else, the NIPS proceedings, anything like that, there's a pretty darn good chance that between R and Python, that's where you'll find, if someone is sharing their implementation, it's going to be in either R and Python, and you can use it almost immediately. So there are some risks, which we'll talk about a little bit, to doing that. But there's a tremendous power that you get from leveraging the full ecosystem of packages in R and Python. So there's been a lot of changes in R over the last decade or so, but there's been an increasing move towards supporting R in enterprises between the Microsoft's acquisition of Revolution Analytics, the founding of the R Consortium, which is separate from the organization that actually manages the core R development, but is instead a coalition of private enterprises, including Microsoft, Google, Facebook, a bunch of other people, all with a tremendous interest in making R scale to use cases like those that we're talking about today. Okay. So as powerful as R is, there are some challenges. So there's some uncertainty around total cost of ownership because it's an open source product that doesn't have support. It has some challenges in integration with existing business data sources, and it has some challenges around scaling up to very large data sets. So all of these are things that Microsoft has sought to solve with the release of the Microsoft R Server and Microsoft R Services in SQL Server 2016. So it scales, it brings the scalability of Revolution Analytics with the direct integration to data sources inside SQL Server 2016 so that there's no longer any need to move data outside of the locations where it's already being stored. And so this is one of the key pushes that Microsoft, one of the key new features that Microsoft has brought to SQL Server 2016. It enables the execution of R directly inside SQL Server. So we're talking about an alternative execution model primarily today around Azure Machine Learning and integration with Azure Data Factory. But with the execution of R inside SQL Server 2016, this is also an option. So instead of running a model through an API call, an R model can be executed directly from inside a T-SQL stored procedure. And so instead of having an external call out to the web service to do the prediction, you can have a query running inside the database that keeps the data in the database and keeps the model in the database and keeps the prediction in the database. So there's no need to worry about security or challenges around any restrictions around data movement. So one of the things that, as I mentioned, how essential R and Python community is in providing advanced analytics value. So here you can see, so I have two different R scripts. I have an R and Python script here that just go into their environment to pull out the list of packages. And you can see that in Python and R, both of these come with all the standard core packages that you need to do predictive modeling in either R or Python. So in the Python world here, you'll see scikit-learn, numpy, scipy, pandas, all the things that are part of your core Python analytics environment are already here. And you can also extend this with additional packages that you upload and attach to a particular module. And in the R environment here, you can see also we have all of the core infrastructure that you need from R to do standard statistical models. So things like the dplyr packages for data transformation, things like random forest and other packages for machine learning and other kind of boosted trees. Data processing with JSON. I don't know if it remembers JSON or JSONio. All the different things that you would be expecting from an R distribution are pre-installed inside Machine Learning Studio, and then you can also build on top of them with whatever your specific needs are. So, to be perfectly blunt, though, this is not a core development environment. So this, when you're working with R code or Python code in here, this is a deployment environment. But we have development tools to help you deploy your R and Python code directly into this environment so that you can manage your modeling and data transformation activities from wherever you want, whether that's a Hadoop environment or a desktop environment or a server environment, anywhere you want, and then deploy the production pipeline into Azure ML directly. So there are two packages, two Azure ML packages, one for R and one for Python, that provide client libraries that allow you to directly take your local R or Python environment and reproduce and deploy it into Azure ML. So as I think the Office team alluded to earlier, there's a move towards making all of the public-facing code available on GitHub, and this is no exception. So both the R package, Azure ML, as well as the Python package, which has a slightly more complicated name here, but is also just Azure ML, are available on GitHub here. And so if we look at the R side, so we load the Azure ML R package and then take any R function. So in this case, we're creating a trivial function here that just takes two numerical values and adds them together. But this can be any R function. It can use any local variables. It can use any R packages that are installed on the local machine. And we publish a web service just by passing some credentials that are specified in this workspace value, and the name of the web service that we want to deploy it as, and then the schema. And then, so what happens here is this function is being investigated by Azure ML and R to identify all of the local dependencies so that they are stored, uploaded, and reproduced entirely inside Azure ML, so that this R function is being moved into Azure where it can be scored at scale and in either real-time or batch scenarios. So if I go here and run this R code, and then go into my, if I now go into my web services in the workspace that I pushed this to, but there's a new web service here, Azure ML R Edition, which is what I named this web service here. And that web service will consist entirely of a single R module that will execute the R code that I developed on my local environment. And so this means that you can use a Hadoop cluster or any other big data scalable environment, whatever you need to do your actual modeling. But when you're ready to deploy it into production, this simple R package will take any of the local data dependencies, any local package dependencies, and push them up into Azure so that you can deploy at scale with ease. So just like in the case for R, there's also a Python package. And in this case, you can do things in the same way in Python, or because Python has some different language features built in, or that are now more or less standard. The Python package here also allows annotations. I can make it bigger here. So these are the test cases that are published as part of the Azure ML packages, or the Azure ML Python package. But you can see here, these annotations specify the API keys, specify the data types, and specify the data types for the input and the data types for the output. But then it's arbitrary Python code in here, just like it is inside the R code. And so once this file is executed, each of these functions will be deployed as Azure ML web APIs that can be integrated into your production pipelines. So one thing that you can do, that you can also do as a development environment, where you don't have to worry about corrupting your local environment, is the Azure ML Studio notebook offerings. So whereas before, up until now, we've been working entirely inside experiments, where we're dragging and dropping these Microsoft engineered modules to build our end-to-end predictive workflow. There are a variety of different engines that are supported in the Azure ML notebooks, including both Python 2 and 3, as well as R. So if I create a notebook here, this is a Jupyter notebook, Jupyter being the new version of IPython notebooks, that acts just like any other Jupyter notebook that you would have installed locally or on a server. The only difference being the infrastructure is all managed by Microsoft in Azure. And so this is a REPL environment where your data scientists can interactively build out and explore their data and have an interactive experience just like they would in a local environment or any other notebook environment. There are some advantages here over experiments for development environments, because this more interactive scenario makes it a lot easier to do a lot of different data exploration activities, as well as visualizations. So in Python, all of the standard, or in R, all the standard graphics libraries work, as well as in Python. So you can use ggplot, you can use lattice, you can use base plotting tools in R, you can use matplotlib, or any of the other plotting tools that you're used to in Python, and all of them will be rendered just like they would in any other notebook environment. I think the most important thing to keep in mind after the talks today is how all of these different things fit together. So we're talking not just about individual products. We're not just talking about the machine learning studio. We're not just talking about Azure Data Factory. We're talking about a suite of intelligence or a suite of products around advanced analytics. And where the real power comes into this suite is how all of these can be combined to rapidly build out advanced analytics pipelines. So it's not just an old-fashioned ETL pipeline. It's might be a hybrid pipeline that combines on-premise data with cloud data with Hadoop, with data warehouse operations, with machine learning, but all of these different things can be combined into a single application workflow using the Cortana Intelligence Suite products.